Good afternoon. My name is Chris Townsend. I am the head of marketing at Imaginatic, and it's my pleasure to welcome you to today's iteration of our ongoing Innovation Masters series. Today we're delighted to have David Ritter from the Boston Consulting Group with us to deliver a fascinating presentation on digital forges. Before we launch into the presentation, I want to remind you that all of the materials that we cover today will be available for download after the broadcast, and you will get an email when those are ready. Also, we will be taking questions as we go along through today's presentation. There will be a few times when we take a pause and we'll answer any questions you've been asking along the way. If you would like to ask a question, there is a questions tab in the GoToWebinar panel on your desktop. Please type in questions here and we will answer them at the first break. Before we actually get into the content today, I'd like to welcome all those of you who are coming to our Innovation Masters series for the first time. David, you can see my screen, yes?
Yes, I can.
Okay, good. So for those of you that are new, a little background on this webinar program and why we do it. It's really about spreading best practices of what we know to be a burgeoning discipline of enterprise innovation. We often talk about how even today there are almost no universities that grant degrees in innovation, but there now are some. And we believe this is an early sign of a really better and better established profession for leading and managing innovation. And hopefully those of you on the line are as excited about this as we are and eager to learn as we all do. What's really driving this? From what we can tell, this is because we live in a different world than we used to. We live in a world of constant change that is fundamentally connected and networked and information enabled. And because of the ubiquity of information, the ubiquity of data, the ubiquity of social connections around the world, not just in local pockets, but increasingly globally. It means that change can happen very quickly in both big and small ways. This can lead to big problems for traditional organizations because it is hard for a large, often bureaucratic corporation to adapt quickly to new trends, often in some cases when you were the one that invented it, or you were the ones that saw it before anyone else did. It is still hard to adapt. Unfortunately, as you can see from some high-profile examples, failure to adapt continuously and organically can lead to real problems, as in you go out of business. And the three you can see on this slide are just the most prevalent examples of what happens increasingly all the time these days, and faster, which is what we think of as either you innovate or you die. What does that really mean? If you think about the 20th century, by and large, before the modern information networked age, most companies competed on making the same widgets better. So selling the same or similar products to the same or similar customers, by and large using the same or similar technologies, or at least technology that doesn't change from year to year, but rather over generations. In today's kind of world, that is fundamentally different, we believe, and has created the need for an innovation capability beyond being operationally excellent. The advances in business and technology and management through the 20th century that capitalized on it, let's say an industrial age, allowed for cheaper food, a better ability for everyone to fly around the country or around the world, lower cost of entering the middle class, all kinds of really objectively good things. And we believe that still today, being operationally excellent is a core capability for any organization, but now it's table stakes rather than the only way in which you can be successful and maintain competitive advantage. This innovation capability, the sort of creative, fuzzy, adaptive ability to respond to all the changes in the world and sometimes even lead them, is also now necessary. So this is something that is really a foreign rhythm for most large organizations that are used to being operationally excellent above all else. And so we've been watching a trend growing for innovation leaders to be a real position and role at leading organizations. And so there was a study put out last year by by Capgemini together with the IESE Business School in Spain that showed that it seemed, roughly speaking, between a third and a half of global companies now have some senior executive accountable for innovation. There is a trend for innovation leaders to appear in the enterprise to help build the innovation discipline. But we know from our experience that innovation leadership is really hard stuff. You're fighting against entrenched interests as well as ignorance in many cases. So typically, in our work at Imaginatic, we have seen this many times. An innovation leader is appointed, but you have very little direction and often quite a lot of pressure trying to push against a climate that doesn't necessarily tolerate innovation very well because of old habits. And so it's very common to have a directive from above and to be endowed with a position, but also have to really scramble on the ground to figure out what you should actually be doing. And that's often a very dicey proposition at first. The innovation leadership is hard for other reasons as well, which you could think of as more bottom-up, as in taking risks and tolerating ambiguity and exploring new frontiers is not something that's in the DNA of most of our large organizations today. And so all of you that are innovation leaders on the call this morning probably are familiar with all of these pockets of real resistance that start to surface when you start doing your job well, because it's often a threat to many people, or it can be seen as something very interesting and potentially very rewarding, but also very risky to get involved in. And so there's a lot of difficult inertia to fight against in being a great innovation leader. And so that's why we have created the Innovation Master Series. Hopefully this can be a great place for all of you innovation leaders to talk about the ways in which it is hard and start to learn from each other. Today's topic specifically is about crowdsourcing, which is certainly one of the bag of tricks that any innovation leader will want to use to help bring the masses on board and involve and build discipline across your organization, and also to generate results that can satisfy your C-suite. Crowdsourcing is a complicated, complex space. It can mean lots of different things for lots of different types of work, lots of different types of collaboration to solve lots of different types of organizational problems. And to help us sort out the right way to think about crowdsourcing as part of an approach to leading innovation is our special guest for today. David Ritter is one of the most well-versed and intelligent folks I have ever met in the innovation space, and has spent quite a number of years both at the Boston Consulting Group and as part of the leadership team of Innocentive, helping companies learn to become innovative and to get their hands around many of these concepts, in particular how to think about crowdsourcing and collaboration in a way that can actually be productive and meaningful for your business. So it's my pleasure to introduce David Ritter. He's a wonderful speaker, and I think you'll get a lot out of his presentation. So with that, I will turn it over to you, David.
Thanks, Chris, and thanks very much for everybody who's attending. Chris, you're going to pass the presentation over to me? Great.
Yeah, you should see it come over in just a second.
Okay, I do. Okay, and if you could just let me know if you are seeing my slides, that would be great.
Yes, yes, I see them. All set. Okay,
great. So this entire presentation is a bit of an extended metaphor, so I'll ask you to bear with me as I go through it. But what I hope that you'll come away with is really some very pragmatic advice about taking some of the work that you're probably already doing and maybe adapting it to a purpose that will give you more specific and measurable innovation outcomes. This is really, I think innovation today, there's so much theory that in some cases the notion of actually getting to measurable economic outcomes through innovation is sometimes lost in the shuffle. So let's talk about campfires for a moment. So campfires are places where people gather. It's a nice place to get together and have a pleasant conversation and to socialize. But there's a different kind of a fire. There are forges. So a forge is also a fire, but a forge is also a meeting place. People gather around forges. but forges are fires that actually produce useful work. And if you look at history, forges have shaped the history of civilization really since the beginning of recorded time. The original capability to melt copper and lead in standard fires gave way to the ability to forge bronze. But to forge bronze, people had to collaborate. People had to come together and actually force air into the fire using bellows or in some cases just blowing hot air, blowing breath into the fire to raise the temperature of the fire to forge bronze. But once bronze came along, which was harder and able to hold a sharp edge, you had the Bronze Age, and the Bronze Age was dominated by cultures who had mastered this technology. Major advances in the Middle Ages to be able to forge steel, to actually take iron and be able to forge it into steel, led to another economic revolution. And even today, the economics of the steel industry are changing dramatically through the introduction of microforges. Microforges, which essentially are electrical forges that can take scrap steel and repurpose it at very, very low cost, which has, in many cases, disintermediated many of the very large steel mills. So the evolution of forges throughout history has changed the way the world works. And I would contend that there is another evolution of the concept of a forge which is happening today, which will again reshape the way that work is done. So today you see many organizations spending a lot of time and money investing in what we'll call systems of engagement. And these are enterprise social networks or collaboration and communication tools that are often deployed very widely throughout the enterprise or sometimes deployed on a departmental or functional basis. So things like SharePoint. Obviously everybody has email, but also instant messaging systems, enterprise social networking systems such as Jive, employee suggestion boxes, electronic suggestion boxes, wikis, and the like. And in many cases, there's sort of an assumption that if you provide these nice campfires, these places where people can hang out, socialize, meet, exchange information, that good things will happen, that will help spur innovation, and that just through providing the facility, a horizontal capability for people to collaborate, that you will be able to help advance the innovation agenda. And there's a notion sort of, if we create these great places, people will come and these communities will develop in sort of a bottom-up and self-generated way. I think our experience shows, and I would say having looked at this for about the last 10 years, our experience would show that these campfires seldom, in and of themselves, actually generate a lot of value. Campfires are not bad. It's not bad to provide places for people to interact and collaborate, and good things sometimes do happen. But I would say that I've seen the pattern that's laid out on this slide several times, where an organization deploys a platform of some kind, whether it's a general collaboration tool or whether it's something more specific around innovation like a Spigot. Spigot being a software package that actually is an innovation-specific set of workflows and capabilities. And there's a certain amount of initial interest. People come to the platform, they check it out, they play around with it. But if you look 6 months later, it's essentially dead. There's no one there. It's like at one point I remember someone referring to it as the neutron bomb effect. You have all this infrastructure, you have all these places for people to meet, all these virtual buildings, if you will, but there's no people in them. And then, so there was this investment made. People look at it and say, well, we've got this thing sitting out there. Nobody's using it. Must be the wrong platform. So another search is launched, and the cycle repeats itself, where they go and they say, okay, well, maybe we just got the wrong tool. We'll deploy a different tool. But sure enough, that pattern can repeat over and over again. I've seen some companies go through that pattern 3 or 4 times over the course of several years. What they should take away from that is the problem is not the software. The problem is not the technology. The problem lies with what you do with it and how you purpose it. And it's actually a really big mistake for IT organizations or any organization to deploy a system, put it out there, even if it's quote-unquote successfully implemented. If it doesn't create value, if it really doesn't contribute anything to the enterprise, then it really was a huge waste. And so the technical success of the implementation is really pretty irrelevant. So what I would like to do is draw a contrast between these general collaboration systems, I will call them undirected collaboration systems, and a concept which is a bit different. But to be clear, the concept of a digital forge actually builds on and can be an incremental and complementary step beyond an enterprise social networking and collaboration capability. So I am not in any sense suggesting that you take everything you've done and throw it away. If you've got a great SharePoint implementation or a good Jive implementation or a strong Imaginatic implementation, you certainly should not throw those things away. But by directing them and focusing them, you can, I believe, achieve a great deal more value. And in order to help you understand that, I think what I'd like to do is draw this parallel between the campfire and the forge. So what does a forge have that a campfire doesn't? Well, the heat in a forge is hotter. And so what allows that to occur is a level of interaction with multiple people involved, driving air, driving intense interaction through that system. There's a raw material, and this is really one of the core concepts here. So a campfire is just there to provide heat. A forge is there to reshape something, whether it's to melt an ore into a new kind of metal, or to take a piece of metal, melt it down to the point where it can be shaped. And this is really one of the key distinctions here. By having something to collaborate around, you can really produce much more significant and measurable innovation outcomes. And we'll talk much more about that as we go through. So in a forge, so you have the thing that you're shaping, you also have the tools that you're using to shape it. You've got hammers and tongs and various other tools that you're actually using to shape that thing. And you have catalysts. You have agents that harden the metal. In the case of digital forges, you have curators and guides and members of the community that are helping to steer this collaboration. And this may seem like a subtle distinction, but actually, in my experience, the difference between, if you add these elements to your collaboration environment, then you actually have an ability to measure innovation outcomes. So let's make this come to life. So I'm going to give you 3 examples here, and then we'll pause for questions after that. So a digital forge at work in the pharmaceutical industry. This is a company that I've had the opportunity to work with over the last several years. They deployed a collaboration tool set that was open to an entire disease area. So in this particular case, it was their oncology area. And into this environment, they injected the raw material of a very specific problem. And the problem that they were trying to solve was the fact that they had a compound which was an essential active ingredient for one of their key drugs. And they knew how to make it in small quantities, but when using that same process to synthesize that compound in large quantities was just prohibitively expensive. And as a result, it really called into question the commercial viability of this product. So rather than just allow people to collaborate around that very vague problem, they actually took the existing synthesis process. So in this case, the ore, the thing which was being shaped in the forge, was the existing synthesis process. It gave the people that were collaborating something very specific and concrete to react to. So they could look at that process and say, at each individual step of the process, they could assess how effective that was and what the costs of it were. They provided a level of tooling around this. So modeling tools, simulation software, et cetera, that allowed people to interact with this process and incrementally refine it, right? Or to understand it and to be able to propose alternatives. And the key here, really the catalyst that brought this to a strong conclusion, was the fact that around this process they were able to organize collaboration between the research scientists who knew how to make this compound in small quantities and the people from the development and manufacturing functions in the organization who really understood how to scale up volume production. And the result of this, through a set of incremental refinements, was a new synthesis process that is dramatically more cost effective. And the numbers that they are talking about here is the order of $50 million a year in savings in terms of the manufacture of this. Now, this is a great result in a specific case where they took this process, they put it into this forge, and they came out with something that was stronger and better. But they also got a critical learning from this. And the critical learning they took out of this was, you know what? we should have the development and manufacturing people much more involved in the upfront process where these compounds are being developed so that they can begin looking at and anticipating the needs for volume production and injecting that thinking into the process early on. So this forge not only produced a great specific result, it also produced a general learning which will change the way that work is done, hopefully to be able to anticipate and address these kinds of problems going forward. So Syngenta is a well-known company in the agricultural sciences space, one of the largest players there. They've taken this concept of a problem-solving forge and scaled it up to industrial strength and high volume. So the notion of identifying a problem that could occur anywhere in their product development process. It could occur early in the concept stage. Is a concept viable? Development, how could we manufacture this chemical or solve a particular problem? And they do a lot of plant genomics, for example, pesticides, et cetera, through the productization and commercialization, problems that are identified across the whole range of their product development process. They feed those into a collaborative problem-solving forge that is available to all of their research organizations across the world. There are 5 locations, thousands of researchers. All of them have the ability to look at these problems and contribute potential solutions, and they run hundreds of these problems through this process every year. So where the previous example was one interesting case in point, this is an example of actually taking this capability to large scale. And one of the very interesting aspects of this process is if you look at the bottom, you see the problem, basically the process that they've built around this forge. Essentially, there is a decision that they make. Once they've identified a problem that they want to try to solve, they actually refine that problem and make a decision about whether they're going to submit that to the internal collaboration platform or whether they are going to take that outside the company and actually solicit ideas and potential solutions from external networks. And in this particular case, they partnered with Incentive, which runs Incentive runs an external crowdsourcing platform where they take these problems, they remove any sensitive intellectual property from them, they formulate them in a way that a broader internet community can engage, and they publish them externally. And then they gather these solutions together and evaluate and refine them to the point where they can be applied in the commercial process. This process, by Syngenta's own analysis, has yielded tens of millions of dollars in benefits in terms of the efficiency of the problem-solving process and the solutions that have come out of this machine. One final example. So Amazon has basically taken their entire website and turned it into a digital forge. Every page on Amazon solicits feedback in one form or another. And they solicit feedback about the products that they're selling, obviously, through all the reviews and the tagging, but they also solicit feedback about the website itself, and they do extensive A/B testing. So they use their website essentially as a forge to drive improvements in the website and also to identify the products that are going to be most commercially successful and interesting. So 3 concrete examples that I think begin to give you a sense of how these forges can actually work. So this is a big deal, and it may sound like kind of an interesting nuance, on top of your collaborative innovation strategy. But I just want to emphasize that what really is important about this is the notion of creating a capability in your organization to experiment at high volume and at low cost. And that's really what forges do for you. This is essential, and the reason that this is essential is because I think everyone has an intuitive sense of this, but this slide is interesting because it kind of shows a numerical measure for it. If you look at volatility, this essentially shows the standard deviation of market cap growth by sector. So that's fancy words to say, how rapidly are firms growing in particular sectors, and how rapidly is the change in growth fluctuating. So the notion that if you were the biggest player in an industry, that you will expect to also be the biggest player in an industry 5 years hence is not necessarily true anymore. In fact, growth rates and market share are changing much, much more rapidly than they ever have before. So Chris mentioned 3 examples of companies that didn't innovate and died. I mean, another one, obviously that comes to mind is Nokia, right? So Nokia had the dominant share in cell phone operating systems a very short time ago, but over the course of the last several years has completely lost that and is now in a distant trailing position behind both Android and iPhone. So the notion that, historically we've owned the space, we can expect, it's our birthright to own it in the future, that is just not true anymore. Companies that are going to survive and thrive in this environment are going to develop a capability to have an adaptive strategy. And adaptive strategy is enabled by experimentation. And developing this capability around forges is really a core enabler of this ability to experiment rapidly, to capture the results of experiments, and to apply them. Experimenting in the traditional way out in reality is very, very costly. So, test launching products, doing surveys and focus groups, which are, inherently expensive and often don't yield particularly actionable results. A traditional R&T going through physical prototyping and long-range, research out in the field. These things are expensive, time-consuming, and risky. So improving your ability to experiment rapidly and improving the yield on your experimentation is absolutely critical to your competitive advantage going forward. And if you do this well, then you will create this virtuous cycle where you develop a culture of experimentation, where experiments yield both success and failures. You learn from both. You learn from your failures, and you develop an ability to both experiment rapidly and to capture the benefits. There's a core example of this. If you talk about this notion of experimentation, really, the Toyota production system historically is one of the reasons why Toyota has been the leading player that it's been in its market for so long, and its culture is fundamentally based on the notion of experimentation. In fact, one of the core elements, the core principles of the Toyota production system is that all work is an experiment. So, I want to put forward the notion that digital forges are a key element in being able to help you establish this capability and culture of experimentation, and that capability is core to competitive advantage in today's rapidly changing world. So with that, I'm going to take a deep breath and ask for any questions that may have come to mind at this point before we go on with the rest of the discussion.
Thanks, David. Great presentation so far. So this is Chris. I'm going to sort of moderate the questions. As a reminder for all those of you that would like to ask something at this point in time, there is a questions panel in your GoToWebinar controls. And if you type a question in there, I'll try and get to it if we have time. David, let me start off with a question that just came in that's on some of your last slides. So you're talking about experimentation as sort of the locus or the modus operandi for digital forges. Is that in conflict at all with execution? In other words, if your primary objective is to experiment and learn, is there any risk that could hamper, getting things done, essentially?
Yeah, I don't think it's a binary choice at all. I think, again, I would go back to Toyota. They experiment at every stage, right? So they measure intensively the execution process. So, they measure the manufacturing process to the nth degree. So while things are getting done, they are measuring them and feeding the results of those measurements, and then they're back into the system, and then they're trying new things. So the Amazon example is another good one. So they do A/B testing. They're observing the work, measuring the work, and then experimenting with new ways to do the work, seeing which work better, and then doing more of the stuff that works well and less of the stuff that doesn't work as well. So I don't think these two things are exclusive at all. I think the notion that prototyping and experimentation only happens at the very front end of a process, like if you're developing a new product, you would prototype the product at the front end, and then you would, settle on a design and then flow that design through the execution process. I think that's the wrong way to think about it. I think you absolutely do want to prototype and experiment at the front end, but you also want to prototype and experiment all the way through, with your refinements, with your incremental innovations, with your processes as well. So now I think actually injecting the culture and the capability to experiment throughout the development and execution processes is actually key to this. Okay, yeah, totally makes sense. How does, so there's a question about testing in the marketplace, in other words, running pilots or very
I suppose you could say, public experiments. Is that part of running a forge? Is that a certain kind of forge, or is that, I mean, so if you're doing forges in some kind of crucible, how do you then translate that into actually launching a product?
So, it depends on the nature of the product, right? If it's a digital product, then the forge and the product can be one and the same, like the Amazon website, right? So essentially, you are experimenting on the thing itself. This is one of the reasons why Google's websites are pretty much always in beta, right? So, Google has betas that go on for years, and that's because they're experimenting and learning. And so the product, is the forge, or the forge, is the product. And I think you'll see that. Actually, one of the examples we'll talk about in a moment, GrabCAD, is a good example of that as well. If it's a physical product, then, or it's something where there's a lot of intellectual property, then you just define the nature of the community a little bit differently. You keep it more restricted so as not to disclose things. I think that there are ways to do this at all stages of the development lifecycle. There's a website out there called Quirky.com that does iterative community-based development of consumer goods products. And they use, their online digital forge to actually refine and do community-based design of gadgets for your kitchen. So I think that regardless of the type of the product, you can do some amount of digital forging throughout the development process. If it's a digital product, then I think you can actually have a very tightly integrated model where the product is the forge.
Okay. Yeah. Just sort of integrate the cycles so that the cycle time is shorter and it's all feeding off itself, basically. So one more question, and then I want to make sure we move on, and we'll answer any other questions at the next break if we can. So there are certainly many folks listening to this broadcast that struggle with the right way to explain to top leadership at their company, so that CEO or the board or whatever, that these kinds of approaches have merit. How would you suggest helping to change that executive level mindset about the right way to go about this kind of thing?
So I think you have to, as quickly as possible, move past the talking to the doing. And I think the great thing about forges, and digital forges particularly, and for example, the kind of collaborative problem-solving forge that we talked about in the examples with the pharma company and with Syngenta, that you can start small on these things and you can run pilots. And the good thing about them is you run very discrete experiments. You run a problem through the system and you either get an answer or you don't. And you either take that answer and apply it to something and get results, or you don't. This is really, really measurable. This is not like putting out a collaboration platform and then kind of watching people talk, or even an ideation tool where you're just generating a bunch of ideas and then seeing where the ideas go. This is much more directed and much more discrete, and therefore much more measurable. So I think, I think getting on with it is key, and then actually being able to demonstrate the success stories and the learnings, both from the successes and the failures.
So I imagine then there's a corollary, which is scoping is really important.
It is, and we see a lot of these efforts starting within a given function or within a given, say, business unit area, right? So you can start small. Getting the enterprise buy-in is key, and if you have the luxury of, the classic story about the CEO of Procter & Gamble, A.G. Lafley, saying, we will get half of our innovation from outside the company. Therefore, if you don't, behave in an open innovation mindset, you're going to be fired. Most organizations don't have a CEO who is that bold or directive on this stuff. So you have to demonstrate the value along the way. But the good news is that if you eat the elephant in bites, in smaller bites, that actually you can do that pretty effectively. So the pharma company example, is a good one. They're taking that success story from that one event that they ran through their forge and using that as a basis to understand how they can integrate this capability more broadly into the business. So in my experience, you should work both top-down and bottom-up. You should certainly have the discussion at the senior executive level, but you need to make it concrete for them. Saying, innovation is good and we're going to go do some innovation stuff is not very effective. Saying, here are some specific things that we can try, and then we're going to come back to you 6 months from now, and we're going to give you concrete results about what worked and what didn't, and we're going to ask you to help us move this to the next step based on a set of data that we've generated that actually shows, what we believe is going to be effective in our specific context.
Yeah, awesome. Great point. I apologize to those that have asked questions that haven't been answered yet. There are a couple other really good questions, but in the interest of time, David, for now I'm going to turn it back to you, and we'll try and address some of those questions at the next break. So back to you.
Great. Well, I'll move through the rest of this pretty quickly, and we can come back to the questions. So I just want to talk a little bit about some external forges. So far we've been talking about forges that you can create inside, and I would recommend that you begin there. For most organizations, doing this stuff internally, building these kind of collaboration capabilities internally, is an important prerequisite and first step towards learning how to use forges externally to actually do more open kinds of innovation. In fact, if you talk to the person at Syngenta that runs their innovation program, Joe Byram, he will say, learning to collaborate inside the organization has been essential for us to learn how to take advantage of more external forms of innovation as well. So actually, in the software industry, anybody that's followed open source software knows that the concept of a forge in open source software is extremely well defined, has a long track record of reinventing the industry, right? So, they're actually, Source Forge is an example of a specific forge. The ore in software forges is the code. It's the software code itself around which people collaborate and iteratively refine it. And, this has generated insane amounts of commercial value. Linux has displaced, many commercial operating systems. MySQL as a database is every bit as capable as most commercial databases for most applications. At Innocentive, when we built our cloud-based application offering, we built it all on open source software stacks. So this is a well-proven concept. Topcoder is an interesting example of a software forge that has taken this whole concept to yet another level. So Topcoder is a community that drives the software development process using a forge model, a community-based collaborative model, but essentially structures the entire process end-to-end using community to do every step, to do the project management, to do design, to do implementation, to do testing. And if you look at the community, essentially you get best-of-breed players, experts, deep experts at each single phase of the process. Well-established capability, and it has produced pretty dramatic results. So Topcoder produced, this was a specific competition that was run on Topcoder that was focused on developing a predictive algorithm around in the genetics space. And so there were 84 solutions produced out of this contest. 16 were an improvement over the previous standard, and one that basically they were focused on the performance of this algorithm. It was almost 1,000 times faster. And that competition cost $6,000. So the notion of many, many eyes on a problem, being able to drive real substantial innovation, in some cases breakthrough innovation, is pretty well established in these open marketplaces. I'm going to touch on GrabCAD here as an example of a pretty well developed forge that now actually takes this into the physical product design process, right? So GrabCAD is a forge. It's an online digital community that is all about 3D design. And there are a number of things that have happened to enable this. So the tools that you can use to do 3D modeling now have come down dramatically in price. In fact, there are open source tools, free open source tools that do 3D modeling in a pretty robust way. GrabCAD is fed on this, so they have, I think, 600,000 modelers now, designers and modelers in their community that share their designs and collaborate through this site. So this is an example of a model that is not a photograph. That is a 3D model, fully rendered 3D model that was developed by one of the GrabCAD members. You can see, that this file has been downloaded quite a number of times, and people. The designers that participate in this, they do it for a variety of reasons. One of the reasons is to just get feedback on their work and actually to market their skills. This is an example of the workbench. This is actually a little model I built just to show you how easy it is. I was actually able to create a little 3D model, upload it here. This is their collaborative tool bench. So this is an example of a tool that allows you to share for other people to look at, but also to annotate and comment on your designs. So this is really generating the heat. The collaboration and the heat. GE is using this capability, this forge, actually as a source for design ideas. So I had an opportunity to meet with the GrabCAD folks last week, and I got an update on this program. This is a challenge, so it's an online contest that they launched. GE launched this, $1,000 prize for the first round to redesign the bracket that is attached to a jet engine that allows you to lift the engine, essentially. Not a core component, but an external component that allows you to basically pick the engine up on a hoist. They got 700 entries from 52 countries in this contest, and the winning entry reduced the weight of this part, still maintaining all the critical engineering specs, reduced the weight on this part by 75%, which is huge for them. And so they are now actually making investments, not only in continuing to use this external collaboration capability, but also to bring this collaboration capability in-house so that the GE designers and engineers can use it within their four walls. So this is real and happening, and large companies are beginning to wake up and take advantage of these kinds of capabilities. Also provides professional development and feedback for the designers and engineers that participate. So this is Flaviano Crespi, who is one of the participants here. You see here he has a GrabCAD score of 7308, which basically is an indication of the quality of his work and the amount of interactions he's done within the community. So he has left 607 comments, for example. He's had 9,714 downloads of his models. So for him, this is a great professional development tool. These open forges actually develop a life of their own, and they generate such an incredible amount of energy. You may be aware that you know, there's an open digital forge called Thingiverse that is primarily hobbyists. On Thingiverse, people began to submit and share designs for things that were controversial, like firearms. So Thingiverse actually censored that content. They said no firearms on Thingiverse. So that community that was working on those designs broke out from Thingiverse and created their own community. Their own community was called DefCAD. And DefCAD has now resulted, for better or worse, in the open source design of a number of working firearms that can be printed on low-cost 3D printers. So these designs now jump from the digital world into the physical world. So if I design something on GrabCAD or Thingiverse or DefCAD and I want to actually make it real, well, I can go to Shapeways. And so Shapeways is essentially the Vistaprint of 3D printing. So Vistaprint being the online print store, you can print business cards through the website. Shapeways essentially does that in 3D. So you upload your design, you choose materials, you push a button, you pay them a little bit of money, they create your product and they ship it to you. And this is not just plastic anymore, this is also high-end metal. So what you're looking at on page 25 here is a prosthetic hand that was 3D printed in titanium by the Oak Ridge National Lab. And so the initial implementation of this was essentially done in parts, but they're looking to print the whole thing together. And it includes hydraulic systems built into the mesh of the hand that would be impossible to manufacture through other techniques. So the combination of these digital forges and these 3D printing capabilities leads to a new high-velocity, high-quality, high-fidelity experimentation and prototyping capability that really has not existed before. And large companies like GE and many others are getting onto this bandwagon, not only bringing these capabilities in-house, but also taking advantage of the ones that live in the outside world. So let me pause there again for questions.
David, I think what we're going to do is, just in the interest of time, hopefully we'll have some time at the end, but I want to make sure you can get through the rest of the presentation. So I would say let's keep going for now. Okay. And in the meantime, everyone who, you know, if you have a question, we are keeping track of those, and we'll try and get to them all at the end when we know we at least got through the presentation.
Great. Yeah, so I'll try to wrap this up in just a few minutes so we can have as much time for questions as possible. So where we want to go from here really is to say, okay, great concept, interesting stuff, probably important, what do we do? Let's talk about your journey from campfires to forges. I would expect, you know, if you're in a large organization or even a medium-sized organization and you're on this call, you probably have some enterprise collaboration and social networking stuff. And again, I'm not saying throw that away. What I am saying is build on it and use that as a basis for creating your initially your internal forges, and then creating a capability to enable you to use external forges as well. So you want to start by assessing where you are. What current tools do you have? What gaps do you have? What kind of design tools do you have? In the context of identifying what are the things around which you want to build your forges? What is your ore? And I'll talk more about that in a moment. And there's a fancy word for these things. They're called boundary objects. Once you've done that, once you've identified the things around which you want to collaborate and improve, and you've got a basic set of tools in place, then essentially you need to put some process in place. You need to establish some goals and values and the metrics that you want to use to assess your outcomes. You need to develop your incentives and your support systems. And then you need to empower your owners, and you need to build communities around this. And I'm saying these things quickly. That doesn't mean they're easy, but there are well understood ways to do that. And primarily, I think one of the key elements we touched on before is establishing pilot programs and learning and being able to feed those results back in to experiment on the experimentation process, right? So in a sense, we're saying, use your initial forays into building forges, treat them as innovation programs in themselves, and experiment and iterate on your innovation process. Couple of just drill downs on that. So when we talk about these things called boundary objects, the ore, or the metal that you're shaping in your forge, they could be a wide variety of different things. Classic example is the clay model of a car in the automotive design process, right? Where the design engineer can look at it from the perspective of how attractive it's going to look on the showroom floor. The aerodynamic engineer is looking at it and saying, yeah, the wind will flow over this, in a perfect way. But the manufacturing guy may say, yeah, you've just defined a car that costs $150,000 to build. They can interact and, if you will, constructively argue around that prototype and reshape it until it meets all of the necessary design goals. So that's kind of a classic example, but many other things can feed into forges, including abstract or digital things like business processes. Right? So information elements. So, you need to redefine the way that you do accounts receivable. You could put that process, your current accounts receivable process, into a forge and allow a collaborative process to reshape and improve that process. You could take raw ideas and refine them, test them, and if you will, harden them in a forge. Many other kinds of things can be put into forges, and determining which the best ones are for you is a process that you can go through, and is a great, actually an innovation process in itself, identifying what the best targets are for your forges. Once you've done that, you need to create a set of incentives, and what I would encourage you to do is to think holistically about the incentives. There are many reasons why people might participate and contribute, ideas or refinements, solutions to problems in the context of a forge. But there are basically 4 core buckets. There are the intrinsic rewards, like it's fun to solve problems, I want to contribute. There are extrinsic rewards, like I'm going to be recognized. This could potentially contribute to my career. And many of these systems also, if they're designed in the right way, some sort of concrete reward, actually, for example, cash prizes or other things, actually do provide incentives. There's some controversy about this. You'll read in the innovation literature some people saying, cash prizes for innovation are bad. I disagree with this very strongly. I have empirical evidence that if they're designed well and applied well, they actually work well. If they're designed badly, they don't work well. So you have to think about how to design them carefully and how they're going to work in your social context and your cultural context in your organization. But I don't think it's true that concrete rewards are bad. Different people engage for different reasons, and they engage for different reasons over the course of a project. So this design is a critical element. This needs to add up to a change in culture over time, and you're not going to get there on day one, but success breeds success, and if you are able to demonstrate measurable outcomes from these processes and document that and to celebrate that, then other people will begin to get on the bandwagon. And that really what you need to do is look for the end state over a period of time to be an experimentation culture that actually tolerates failure, but also has measurement that says we're not going to just fail over and over again. Tolerating failure is one thing, but if you don't learn from the failure, then you're doomed to repeat them, right? So really having an effective capability to, have creative dissatisfaction with the status quo, apply the right tools and incentives that get experimentation going, measure it, apply the outcomes, and to use that repeated cycle to to actually build the capability. Major companies are using external forges through partnerships all over the place. So once you've got your feet under you with respect to this kind of capability, there are lots of opportunities for you to work with these external forges to supplement the way that you do problem solving or design improvements in the outside world. And I think that there is real power in these approaches, a lot to learn in terms of how you deal with them appropriately with respect to intellectual property and other things. And that's part of building the capability along the way. Unfortunately, if you're going to use these things, these external marketplaces and innovation forges, you really are probably going to have to get your lawyers involved eventually. But the good news is that many of these places actually have well-established intellectual property structures that can help you do that in a way that is pretty well protected. So, but I think that as Syngenta approached it, really looking at this capability holistically to develop the ability to have forges internally, but also connect to external forges, both of them are actually quite important. So just to sum up, campfires are great. There's nothing wrong with providing people places to get together and talk. Forges actually drive measurable outcomes, and I think that that's key. And the way they do that is by enabling experimentation, and experimentation is a critical survival skill in a volatile world. You need to put the right elements into your forges. You need the right raw materials. You need the right tools. You need the right catalysts. And you can tap into existing external forges, but you should also create your own, both because they will create an insane amount of value and also because they will help prepare you for taking advantage of this capability more broadly. And the way to do that is to pilot, experiment, learn, and iterate. Apply the forge concept to your forges. With that, I'd like to turn it back over to Chris and take additional questions. Thank you very much.
All right, thanks, David. That's great. We are almost at the top of the hour. For all those of you that need to leave the webinar to get to another meeting, feel free. David, are you available to stay a few minutes over, say 5 minutes over, to answer a few questions, or is that not possible for you? Okay.
Yep, I absolutely. So,
okay, great. So for anyone that can stay on for about 5 minutes past the hour, we'll try to stay on for a few minutes to answer some more questions. Here's one that came up a little while ago that I think is really interesting. There's a question about cost in terms of these experimentations. So let's say the first time that within an organization you embark on a forge-based experiment, you may not understand very well what the cost or time involved might be. How do you think about managing costs in conjunction with experimenting in this way?
So there's a small scale approach that you can take with respect to pilots where just basically doing the experimentation in a digital sense is very low. And I think that that's, depending on your appetite, where you are in the maturity of innovation within your organization and the level of investment that your organization is willing to put forward on this, essentially taking an existing social networking platform like SharePoint and structuring a process around it to be able to do forge-like innovation in that context, picking some specific pilot targets, this can typically be done at very low cost. Then the question is, what do you do with the outcome of that? And I think this is actually a core point. If you do a lot of experiments and you have a lot of results and you're not able to apply those results because you don't have any budget to do anything with the answers, that's bad. And that actually turns into a disincentive for people to participate. So I would look to try to define your pilots in a way where you actually have participation from the business owners who are going to take the results of this. They're working on a real business problem or developing a new innovation which is going to have value for the business, where you know up front that the business, if they get a good answer, if they get a good design, that the business is highly likely to carry that forward. So you get owners from the business involved, and that drives the sponsorship for these pilots, that you're not focused in some theoretical sense, that you're actually basically working on real business problems that have value and therefore can drive funding end-to-end in terms of not just the solutions or the designs, but also the application of those things. And then you scale up from there. I mean, you should be able to measure the outcomes from these things in a pretty incremental way and be able to add that up to a business case that can lead to the capability to build more infrastructure. Chances are good you also already have a lot of this stuff going on in your organization now, And if you're spending a fair amount of money on enterprise social networking, you may have an opportunity to redirect some of that spend towards some of these more focused activities that actually have better outcomes.
Yeah, I think that's a really, really important point, this idea of not creating a forge, let's say, in a vacuum divorced from activities the business is already pursuing or needs to pursue. But if you can integrate it with something that already matters to the enterprise or is an existing process that can be augmented in this way, then that you can work hand in glove rather than potentially be at odds or have a weird conversation about cost or funding. Let me pick off another one. There's so many that are interesting to tackle. With respect to industries and applications, David, a lot of your examples have been around making stuff, whether it's 3D printing or software or something. If you're in a services industry,
Yep.
Does this model work as well? And if it's different at all, how is it different?
Sure. So services are products, and products have definitions, and so services have processes around them, for example, right? So you have a customer care process if you're in the service business, right? So that process could be the thing that you put into the forge. So how do we make our service processes better, right? That could be one thing that you put into the forge. The other interesting thing about processes in the services industry, of course, is they involve customers. So you could think about extending your forge to include customers, either selectively or broadly, in terms of being able to comment and provide feedback on your services, right? So don't restrict the notion of what you put into your forge to just be a specific product or a design. It could be an underlying process, an enabling process. It could be your customer value proposition could be something from a services standpoint. How do we enhance the value of our services to our customers? Could be a problem that you put into your forge. So as long as it's a well-defined, concrete thing, like the sand in an oyster that results in a pearl, right? It's the thing around which people collaborate that gives them an anchor point and a direction and a notion of being able to get a measurable outcome. There are many things in the services environment where that you can apply this concept to.
Okay, great. I think this may be the last question we have time for, but I want to get to it with the last few minutes. You touched on it a little bit before, David, about IP. And especially when you're going to an external audience. I'm wondering for maybe a little more commentary on, let's say you go through, there was an early slide where you had concepts through, develop prototype all the way to commercialization. As you go through that whole process, you're inevitably, I would think, going to be involving different types of stakeholders, potentially in different types of forges, I would imagine. How might you, within the enterprise, manage access and IP and actually, of course, there are legal issues as well involved, but also just the nature of collaboration. How do you manage that as the life cycle proceeds?
So yeah, it's a broad question, and I think you need to have an intellectual property scheme and a process within your organization to do this. And this is why I think as you embark on your journey to define your forges, you need to involve your IP folks. If you're going to go down the route of using these external capabilities, unfortunately, and if there are any lawyers on the call, I will apologize in advance. In many cases, the job of your lawyers is to say no to things. They're not used to thinking in these ways, and so bringing them on this journey and educating them about what works and what doesn't. There's lots of good examples out there of companies doing this successfully and doing so in a way that protects their intellectual property. There is no scheme of interacting with outside folks that is without risk, you're going to have to take on a measured risk, and this is where executive sponsorship is key, because at some point you need an executive to walk into the room and say to the lawyer, you know what, I understand that there's risk associated with this, but it's a risk that is acceptable from a business standpoint. The value makes sense, and we're going to take that risk.
Excellent.
So
Excellent.
I am unfortunately going to need to drop off at this point, but I hope people have found this useful, and I'm happy to follow up if folks would like to do so after the fact.
Well, thanks, David. Appreciate it once again. It's been a pleasure having you on. To everyone that's still on the line, we will have materials from this broadcast today, including a recording available within the next day or two. Please stay tuned. There will be an email coming out, and it will include ways to interact with both us at Imaginetic and with David. And please do stay tuned. There are we have a full lineup of webinars in this series planned for the next few months as we go through the fall. So stay tuned for emails from us on our next set of speakers. So thank you again, David. Really appreciate the time today. And to everyone else, have a wonderful day.